We're going to do one last example using partial fractions decomposition. This one's perhaps a little more involved when it comes to integrating the final result. So let's try to integrate the proper rational function 1 over x times x squared plus x plus 1. And notice the denominator here has two factors, a linear factor x and an irreducible quadratic x squared plus x plus 1. You can check here that b squared minus 4ac is less than 0 for that quadratic. So we start with the partial fractions decomposition. We include one term for the linear factor a over x and one term for the non-repeated quadratic, irreducible quadratic factor of the form bx plus c over x squared plus x plus 1. And now we multiply by the denominator in our rational function, and we multiply both sides and cancel what we can on both sides. So we end up with just a 1 on the left-hand side, and on the right-hand side, the first term after cancellation gives us a times x squared plus x plus 1, and the second term after cancellation gives us x times bx plus c. And expanding, we get a times x squared plus ax plus a plus bx squared plus cx on the right. Now gathering up the terms on the right and comparing the coefficients of the powers of x, we get the coefficients of x squared are equal on both sides, so we have a plus b is 0. The coefficients of x must be equal on both sides, so we get a plus c equals 0, and the constant term must be the same on both sides, so we have a equals 1. So substituting a equals 1 into the other two equations, we get b and c are both -1. And the partial fractions decomposition of our rational function is 1 over x minus x plus 1 over x squared plus x plus 1. And of course the integral of our rational function is the sum of the integrals of the terms on the right-hand side. The first one is easy. It's the integral of 1 over x, so that's the natural log of the absolute value of x, and we're going to have to work a little bit on the second one. There are a couple of ways to go about this. We could break this up into two fractions, the first one for which a substitution works and the second one for which some trigonometric substitution works, or we could start by completing the square of the denominator and then making our substitution and then breaking up the integral, which is the path we're going to follow. So we're going to calculate this integral in blue, and then we're going to go back and substitute our answer into our expression for the integral for our original rational function. So let's start by completing the square of the denominator. X squared plus x plus 1 is x plus 1/2 squared plus 3 over 4. And now we can make the substitution u equals x plus 1/2 and replace x in our integral by u minus 1/2. And of course du is equal to dx here. And now our integral of x plus 1 over x squared plus x plus 1 becomes the integral of u minus 1/2 plus 1 over u squared plus 3 over 4 times du. And tidying this up, it becomes the integral of u plus 1/2 over u squared plus 3 over 4. Now we can break up this fraction into the integral of u over u squared plus 3 over 2 plus 1/2 the integral of 1 over u squared plus 3 over 4. And the integral on the left we can solve using a substitution. W equals u squared plus 3 over 4, and for the one on the right it's tan inverse. We can use the formula for the integral of 1 over u squared plus a squared, where a here is the square root of 3 over 2. So the integral on the left after substitution becomes 1/2 the natural log of the absolute value of u squared plus 3 over 4, and the integral on the right becomes 1/2 2 over the square root of 3, which is 1 over a, times tan inverse 2u over the square root of 3, which is u over a. And now converting back to x values, we get this is equal to 1/2 the natural log of the absolute value of x squared plus x plus 1 plus 1 over the square root of 3 times tan inverse 2 times x plus 1/2 over the square root of 3 plus a constant. And now going back to our original integral, we have the integral of our original rational function is the natural log of the absolute value of x minus the one we've just calculated in blue. So it's the natural log of the absolute value of x minus 1/2 the natural log of the absolute value of x squared plus x plus 1 minus 1 over the square root of 3 by tan inverse of 2 over the square root of 3 times x plus 1/2 plus a constant.